All right, so the request has been that I solve problem. Whoop! It want to freeze on me. Is it going to move? There we go. Good. All right, so I've been asked to solve number 28. And 28 says an amount of hydrogen chloride gas has a volume of 1.51 times 10 squared liters. Well, let's start out by making out our list of knowns and unknowns then. This is number 28. So we have a volume of 1.51 times 10 squared liters. Okay? And reading further in the problem, it says at a pressure of 1.11 times 10 cubed kilopascals. P is our symbol for pressure, and that's 1.11 times 10 cubed kPa. All right? And a temperature, let's do temperature here, I guess. Temperature is 12.0 degrees C. And it asks you to find how many moles there are. Well, our symbol for moles is N. Technically, N actually stands for the amount of gas. However, James, the amount of any substance is measured in moles. It's the SI, moles is the SI unit for the amount of substance. All right. So we've got V, P, T, and N. Those are the variables. V, P, T, and N. And if we go through our list of known gas laws, the ones you have to use in here, they're all grouped right here on your test references. And this equation right here has V, V, P, T, and N. V, P, T, and N. The only thing we don't have in our list so far is R, but you have to know that you always have R. R is always found on the front page of your test references, and there are 6 different versions of R. You have to pick the version of R that fits the measurement units here. So we've got liters. There's liters. You got kilopascals. Well, that's not kilopascals there. It's down here. This has liters in kilopascals. There's Kelvin in this, but we also should know that you've got to change your temperature to Kelvin. We can't do any gas law calculation without temperature in Kelvin. So we know we're going to convert this to Kelvin anyway. So that would work there. And we've got N for moles. So there's moles. So this is the version of R we're going to want for our equation. So N is our question mark. R has to be that version of R that best fits our units of measurement, and that's what we have here. 8.314 liters times kilopascals over Kelvin times moles. All right, we've got everything except we need to convert this to Kelvin temperature. So we have 12.0 degrees C, and we have to add 273.15 to that. 5, this is 5, this is 8, 285.15, but we've got an empty slot above the 5, meaning that this 5 has to be rounded off. We're going to put a line under the 5 to show it has to be rounded off, and draw an arrow to show that we are rounding. So the difference between this answer and the next one is a rounded process, 285, and this 5 here makes this 1 round up to a 2. And this is the temperature in Kelvin. So the temperature in Kelvin, 285.2 K. And now we have everything we need for the equation PV equals nRT. Yeah. So we're ready now to plug in. We're ready to plug in all of these. However, you have a choice to make here. Okay? The process that I taught you in this unit is to plug everything in and then isolate the unknown. But what I told you yesterday is if you prefer, you can isolate your unknown first and then plug in. Alright, so let's take a vote. Choice 1, plug in then isolate. Choice 2, isolate then plug in.
Isolate first.
Everybody want to plug in and then isolate? Raise your hand. Everybody that wants to isolate and then plug in, raise your hand. Okay, looks like plug in and then isolate wins. All right, that's what we're going to do. So I'll plug in my known values first. Pressure is 1.11 times 10 cubed kPa. Volume is 1.51 times 10 squared liters. Oh, I need to turn this sideways. I'm going to run out of space. How about I take another sheet of paper and I move it down here and I'll turn it sideways. Is that okay? I need some more space. Okay? To make this work out. Alright. 1.11 times 10 cubed kPa times 1.51 times 10 let's see, times 10 cubed liters. Okay, and that's going to equal, we don't know what N is, so we're going to leave N alone. Going to multiply that times R, 8.314 liters times kPa over Kelvin times moles. Yes. And then T. All right, folks. I hear a lot of chattering and things like that, and I'm sorry I'm boring you here, but these are the things you have to do on a test. Okay? But I need you to focus. Now, if you want to stand up and stretch a minute, we can do that. But we've got to be able to solve problems like this. Okay? Huh? Well, there's a lot to it, but if you just follow the step-by-step process, it all works the same way. Okay? All right, so here's temperature. Temperature's 285.2 K. All right, now I'm going to isolate the unknown. Okay, and this is where we're going to kind of run out of space here, so I'm going to have to write kind of small over here. You have to know what we're writing. Okay, you should be writing this down with me, not waiting till I'm done and then try to copy it down. So that when I put these down, you don't have to ask me when I'm done, what does that say over there, Miss Tedder? Okay, follow along with me. All right. Over here, I've got to get N by itself. And to do that, I've got to multiply by the inverse of both these fractions. Okay, you can call it whatever you want. You know, I call it invert multiply. All right. So I'm going to use a slightly smaller pen here so I can get this squeezed in here. Kelvin times moles, because that's on the bottom here. I need to put it on the top there. I need to put this on the bottom there. 8.314 liters times kilopascals. All right. And then I need to invert this one as well. And I'll have 1 over 285.2 K. Now what that allows me to do then is to cancel this number because I got the same thing on the top and bottom. Cancel liters because I got the same thing on the top and bottom. Cancel kilopascals because I got the same thing on the top and bottom. Cancel this number because I got the same thing on the top and bottom. Cancel Kelvin. Those are on the top and bottom. Cancel Kelvin again. And cancel moles again. Or cancel moles, not again, but Kelvin again, but not moles. Okay? All that's canceled. But I added this to the equation over here. And whatever I do to this side of the equation, I must do to the other side. So I've got to go to the other side and multiply by these same two fractions. All right, let's move over here. And I know this is going to be kind of like off the screen a bit. Maybe I can twist it sideways a bit so you can still see a little bit. Okay, so I'm going to take and put these two fractions over here. So let's see, 1 over 285.2 K. And then times this inverse here. All right, so I've got Kelvin over moles, or Kelvin times moles over 8 1.314 liters times kilopascals. Liters times kilopascals. Okay? Now, just to be able to do the math here, let's put these over 1, because remember, when you multiply or you put anything over 1, it doesn't change the value, but it's getting everything kind of lined up for the next step. We're not changing the amount of these numbers. Dividing by 1 gives you the same number. All right. But this allows me then to see that, oh, I can cancel these kilopascals here and here. And let's see, I can cancel these liters here and here. And I can cancel Kelvin here and here. And when I cancel all those things, I can see I've got N for the amount of substance, and moles over here, and moles is what measures the amount of substance. So I'll probably set my math up correctly. All right? Yeah, Elena? Yep. Okay, so let's do the math now. Okay. So there's no number here. There's a 1 here. Multiplying by, dividing by 1 doesn't do anything. We can ignore the 1. I need to put in this number. 1.11 times 10 cubed. Now you can use the times 10 up caret 3. That's a lot of things to put in there. Or second double E and 3 gives you the same number. Okay? Second double E 3 gives you the same number, and that's a little bit easier to put in. Okay? So that's a sort of the scientific notation way of putting it in. All right? Then I can multiply that times 1.51 second E2, because that's the same thing as 1.51 times 10 squared. That's everything across the top. I need to multiply that first. However, I'm going to do one thing before I do that, because I want to try to help you set yourself up for success with other kinds of problems. It will be better since I have multiple types of problems going on here. I've got this exponential problem times this exponential problem. So this is one function, this is another function, so I got function inside a function here. So let's separate the functions with parentheses. It'd be better if we did. I mean, you'll probably get the right answer for this, but this never hurts, and for some things, like separating out addition and multiplication, you have to do that. So it's just better, I think, if I just teach you to do this each time. Oop, I put in the wrong thing here. There's a 1 there. 1.51 times 10 squared, and close that parentheses there. Okay? So you see how I've got it put in my calculator now? I think that'll help you if you try to remember to separate your functions by putting things in parentheses. All right? Anybody confused by that? This is going to help you in algebra too. All right? Not algebra 2 then, class, but algebra also. All right, so now I'll multiply everything across the top. I'm going to hit enter. Now I'm going to divide separately these numbers on the bottom. So divided by 8.314 and hit enter, or equals. Then I'm also going to hit divide by this second number, 285.2, and hit enter. Okay, and that's the answer I need for moles. At least before I round it off, it's the answer I need. So I need 70.687.13581. And the units I have left are what? Moles. That's what N measures. N measures moles. But I have to round off. How many significant digits do I need in the final answer? 3. Because this number and this number both have 3 digits. 3 significant digits. Both of these have 4. We want the least digits for our final answer. We want to find the measured or calculated numbers in the problem, choose the one with the least digits, and make our final answer have the same number of digits. So the first 3 digits are significant. Everything after that then is insignificant. So that's how we show they're insignificant. That's required. The arrow is the mathematical operator we use to show we're rounding off. You can't use an equal sign. It has to be an arrow. And so this is 70.8, makes the 6 round up to a 7 moles equals N. And there's our answer. Okay? Yay. Good. Okay? All right. So we're taking all these algebra skills you've been learning. Some of these things you've been learning since elementary school. All right? Some you've just learned in high school in Algebra 1. But we're putting your algebra skills to practice in real world ways, because this stuff really does happen. It's not just numbers we're using. We're actually figuring out the behavior of a gas by using algebra. Okay? And science requires a lot of mathematical ways of doing things give you a much surer, S-H-U-R-E-R, surer way of showing your answer to be correct, that you're supporting some argument. And that's what science wants to do, support arguments. Okay?